Hello. We will now calibrate the potentiostat with this procedure. First of all, we have 6 cables in here, which are different colors, and we're gonna take this dummy cell, which is inside of this Faraday cell, and now we're gonna check if this side says calibration or EIS dummy cell, which is like so.
Electrochemical incidence spectroscopy.
Correct. So we should use this side always, and the good thing is that we have labeled here which cables are on what side. So I'm gonna connect everything, opening this crocodile, I think it is called, and then we're gonna make sure that the cables don't touch. So this crocodile should be on this side. So, and this crocodile should be on this side. Okay, so it's very important for the cables to not touch, so we have to place it like so, and then we're gonna do the same for this other side with the red, with the white in here, the reference, and finally the orange cable, which should be here, placed like so. So now that we have everything connected, we gotta make sure that nothing is touching again. This is why we have this protection in here, which should stop the cables from touching. And when we have that ready, then we can place it like this, noting that the cables should go on that side. Once it's placed, then we align everything correctly like this. So now that everything is aligned, we close the Faraday cell, then it should be ready to calibrate when putting the black cable, which is the earth, I think that's what it's called, in here. Now we're gonna go to the computer, and in the computer we have this program called Gambri Framework. We're gonna open it, wait for a few seconds, and when it is ready, we're going to go into experiment, then utilities, and calibrate instrument. Okay, so the start device list is empty, of course, because it hasn't been started, so we can turn it on that switch, and now it should be ready to go. We gotta wait for the, okay, now it says device is present, identifying, and it's now on green. So we're good to go. We're gonna go into utilities, then calibrate instrument, and say OK, because this is a potentiostat. We're gonna calibrate both types, both for DC and AC. I'm gonna go OK. Then it will ask for some information and for some clearances, which are connecting your cell leads to the calibration side of a universal dummy. And this is OK. Unit should be fully warmed up, and it should be. And now we're gonna start the calibration. And that's it. We gotta wait now 8 minutes, and then it will be ready.
And now this is calibrating.
Okay, so we're gonna take a sample here, check the name, of course. It's a good procedure. And then, well, this is the setup for the electrochemical cell that we're going to use for potentiodynamic and OCP, open circuit potential tests. And we have this cell here. We use this geometry because of the size of the sample. And because, of course, this lab is not ours, so we don't want to mess anything up. So we're going to use this one. And it's composed of these parts, which is the upper body and the lower body. Okay, they are going to be attached like this. Thanks to some bolts, which are this. So, okay, what we're gonna do now is to put a sample in between and check if the geometry can fit the sample.
And I think we should clean the sample with acetone or isopropyl alcohol, so that not to touch the surface.
Correct.
And we have actually optimized the setup according to our samples.
Yep. And now, considering we're gonna clean it when we do the test, right? But considering that we're gonna try now to see if everything fits well, we're gonna put the O-ring, which is this white thing, which is flexible, and we're gonna put the sample in the center. It doesn't need to be perfectly aligned at the center, but we gotta make sure that it is well put. Now we're gonna put this, which is
Copper,
right?
the working electrode.
And the working electrode, correct. So this is gonna be just a connection to the sample.
We can put it at the bottom? No?
No, we gotta put it here so it's connected to the sample. Okay, so now we're gonna place this O-ring on top, making sure that everything is centered. Okay, and we're gonna make sure as well that this is
On the back side, okay.
okay on that side, because we want to corrode the center, which is the gray part, not the copper. So we're gonna bring it there, and now we're gonna close it. We're gonna close it here, and we gotta, maybe this is a better way to do it. First, second, and third. Now we're gonna put everything like this. Okay, so now we gotta move it around maybe to check that it is aligned. Hopefully it is. Okay, so now it is aligned. So before doing anything, the sample is in between. Okay, so this is my first time trying this out. So okay, the sample is in between and there. Now we can put maybe the copper. Yeah, maybe we could put it below the sample, or maybe like this. Now we check inside. Maybe the phone won't take it, but we gotta be checking the inside. And now that we've checked, we close everything up.
Maybe we can put the screws from the back side to the upper side. What do you say? To tighten it. So we have put in the wrong side.
Yeah.
So from the down to up we can use.
Yeah. And now we gotta tighten everything. So the problem now is that this is gonna be a little bit tricky because.
No, I'm saying we can use this one on the bottom side, and that will be good to tight.
Yeah.
It will be very easy for us to tight.
Okay. So I'm gonna do that then. Now I'm drying the surface, the sample. After it was washed and cleaned with ethanol, we gotta make sure that everything is dry enough to be able to test it, and this should be good enough. No more than that. No high intensity as well. Okay, now after the calibration is done, it will ask to calibrate the thermocouple. Okay, then it will say no because we don't have a thermocouple, and then it will say calibration complete. That's it. And we calibrated the instrument successfully. So now I'm going to place in the sample in here and put in the bolts first. That. And then this side should be up. Why? Because this is our marker that we've already filled it up with 10 milliliters. Okay, so we shouldn't go past that. Now this is the tricky part, which is putting this. Okay, so we're ready. Now the problem is that the bolts are a little bit short, so we can push it like this. Okay, we'll push it and you gotta tighten as much as we can.
But we have to put some screwdriver from the bottom.
Yep. So we screw this now. We gotta tighten it as much as we can without damaging, because we don't want any leakages. We start to feel some pressure, some resistance, shall I say. And as you can see, this is almost completely sealed, and there's a little part in there that I need to make sure that it counter electrode and the reference electrode, this one. This is silver and silver chloride.
This is a reference electrode.
Yes. Before putting a new test, we gotta wash it in deionized water, which is this this thing, and then we're gonna give it a little rinse and then dry it just by gently tapping, not like you would dry anything else. Just be gentle with this, and then go on and fit it inside of this thing here. It should fit right.
Silver chloride. This is the calomel electrode, right?
Correct. So we're gonna fit it there, ensure that it doesn't go out, and this should be like so.
Yeah.
Okay, so now we're gonna do the final test, which is basically pouring the sonogram fluid into the.
But you can use, you can take it out and you can use some.
Oh yeah.
Some medicine
to measure. Yeah. So I'm gonna take out the.
Here we have different electrodes and their potential. So now we are putting synovial at a very high. You put.
Yeah, I put it a lot. Bit too much, but it looks fine. It's not.
It's not leaking, right?
No, it's not leaking. So yeah, now we're gonna put this thing on top and make sure that everything is submerged. Okay, so it should be like this. We don't have to put too much pressure, it's not necessary. We just gotta make sure that everything is drowned and then or synced, really. Now we also finished the calibration of this instrument, so we're gonna take out the cables. And then we're gonna connect to this. Can you pause it a little? I need to check something. Yep. Now we're gonna grip into the copper, this one, with the green cable. Then it will be followed up by the blue cable, which should be connected on this side, like this. Then we're gonna put the white cable to the reference electrode. I mean, this setup really should be here so that the cables are not too tense. Then we're gonna put it here, sorry, on this side, gripping that. And then the red cable goes in first with this. Okay, and finally the orange should be gripping like so. Okay, so maybe the setup could be improved a little here. Maybe we could pass the white cable around from this side and then grip it from here. Yeah, that is better. Okay, so this goes here now. We might want to take the chair out as well, just to make sure that the black cable is not touching anything and is just on clean air. Then we, of course, we want to store everything. So now we're gonna go again into experiment, sequence wizard, And now we're gonna check the Gamry sequence, which is composed of two tests. First of all, an open circuit potential. We're gonna double click and then check for the correct file name. We're gonna update this to the date of today, which is the 28th of July. And then the name seems to be alright because this is the OEM sample, right? Now we're going to do an OCP standardized for 3600 seconds, which is equivalent to 1 hour. We're going to say OK. Then for the potentiodynamic test, we're going to check and we're going to scan the sample from minus 1.5 volts to 2 volts with a scan rate of 1 millivolt per second. So this test should take around 45 minutes. Okay, we're going to check again the file name, which should be this one, and we're ready to go. Yeah. Okay, so now that we're ready and nothing is leaking, we're going to check that. It looks fine, and we should run sequence. And when running sequence, it will start automatically, and then we start to see those points, which are signaling that the system is now running.
And now the test is going, so it will go until 1.5 hours, and then we'll see what kind of plots we will get. And you can see here the curve, okay, nicely obtained with this setup.
Yep.